Okay, hello everyone. This is your instructor, Physics 211 instructor, Dr. Chai Huang, and now I'm just going to work on the problems, and record them. So the first problem that I want to do is from Chapter 2, Problem 3. So this is Chapter 2, Problem 3. Okay, so here's the problem. An automobile travels on a straight road for 40 kilometers at 30 kilometers per hour. It then continues in the same direction for another 40 kilometers at 16 kilometers per hour. What is the average velocity of the car during the full 80-kilometer trip? And assuming that it moves in the positive x direction. And what is the average speed? And you want to graph the position versus time, indicate how the average velocity is found on the graph. Okay, so after you read the problem, then you need to write down, associate the symbol with the numbers. So we know that, so this is the diagram. Let's say if you take this initial position, so it's moving from this point to that point, and the x is 40 kilometers, and it's moving at a velocity, and so we call that v1, and this is your the distance, we call that h1. So your v1 here is 30 kilometers per hour. And then the car is continue to move another 40 kilometers. So that's say from this point to that point, that's additional 40 kilometers. And the velocity changes velocity. So the velocity now is 60 kilometers per hour. Now, normally you want to use the SI unit, but for this problem, you don't have to use the SI unit. You can just keep the kilometer and per hour, okay? So in that case, when we want to find the average velocity, basically, how do we find the average velocity? You need to know what equation to use. So this is the equation. The AVG is defined as, the average velocity is defined as the displacement over the time that the displacement took place. Okay, so what is the displacement? The car initially starts at this point, it goes 40 kilometers, and then it goes another 40 kilometers. So we know that the displacement is just 80 kilometers, because that's the from this initial point all the way to the final point. Okay. Now, what about the time? How much time the car takes from this point to go from this point to that point? So we really need to calculate our T1 here and our T2 here from the second point on to the final destination. And then so the total time interval will be T1 plus T2, okay? So in that case, we need to calculate our T1. So how do we calculate our T1? T1 basically, the time it took for the car to move from to move 40 kilometers, if you know the velocity v1, which is 30, so you have 1.33. That's the amount of time that it takes. And then what about your T2? For T2, you have the distance, which is also 40 kilometers, and then the velocity changes from to 60. So what we have here is that after you find this, you get 0.66. And I'm sorry, this is actually in hours. So that would be 0.66 hours. So in that case, what is the delta T? Your delta T now becomes T1 plus T2. So we have 1.33 plus 0.66. So what we have here is that the average velocity would just be 40.2 kilometers per hour. Okay? So that's basically how you find the average velocity. Now, what about average speed? To find the average speed, the difference between average velocity and average speed is that the average speed is equal to the total distance. So I'm just going to say total distance over the total time. So in this case, the total distance is from this point all the way to that point. So that total distance is the 40 plus 40. So that's your 80 kilometers. And then your delta T, what is your delta T? Your delta T again does not change. That will be T1 plus T2. So you still have 1.99 hours. So after you do the math, you still get 40.2 kilometers per hour. So in this case, you can see that the average velocity and the average speed, they are exactly identical. It's not, it may not be always the case. Okay, so I just, so this is the that one. To graph it, basically you have the, you're going to plot position versus time. So in this case, you have your from 0 and you have your T1 and you have your T2, and this is your X1. So that will be your X1, this is your X2, so you see that you have something like this. Now, during the first time interval, it's moving at 30 kilometers per hour, so you have something like this. And then during the second time interval, it's actually moving at a faster speed, so you expect that the slope is a bit steeper than the other one, okay? And how to find the average velocity? Of course, if you so basically we'll just use that will be just slope on the curve. So it's delta x over delta t, okay? So that will be, so this is your, the first problem, that is problem 3 that we done. Now, the other problems that I want to do, let's move on to the next problem, which is problem 19. And I'm just going to erase the board. Alright, so problem 19, at a certain time, a particle had a speed of 18 meters per second in the positive x directions, and 2.4 seconds later, its speed was 30 meters per second in the opposite direction. What is the average acceleration of the particle during that 2.4 durations? So when you read the problem, again, you want to associate the number with the symbols. So we know that the time interval is 2.4 seconds. So you have your t, which is 2.4 seconds, okay? And it says that the speed, is 18 meters per second. And then after 2.4 seconds, the speed becomes 30 meters per second in the opposite direction. So if we take it to be the initial value, so we call that VI, which is 18 meters per second, then 2.4 seconds later, we call that VF. And that VF, it has a magnitude of 30 meters per second, and it says that it is in the opposite direction. So we're going to associate that negative number with this 30 meters per second to indicate that it is in the opposite direction. And you'll also find the average acceleration. So again, by definition, the average acceleration is defined as your VF minus VI, or the delta V over delta T. Okay, so now because we have our initial, we have our final speed, we have our initial speed, so we can just directly plug in the numbers into this equation. So you have negative 30 minus 18, and then over the time, which is 2.4 seconds. So then after you do the calculation, you'll find that the value is, so you have negative 48 over 2.4, so you have negative 20, and the unit is meter per second squared. So this is basically the average acceleration for when the velocity changed from 18 meters per second to the negative 30 meters per second. Okay, so that's this is problem chapter 2, problem 19. Okay, and the next problems I want to go over is problem 23. So I'm going to Alright, so problem 23. An electron with the initial velocity that's 1.5 times 10 to the 5th meters per second enters a region of length that's 1 centimeters where it is electrically accelerated, emerge with the velocity. So emergent velocity, so we call that the final velocity, which is 5.7 times 10 to the 6th meter per second. What is the acceleration assumed constant? So this is a diagram. So basically, you have a distance. You have electron that's entering from the left, and then go through this this accelerator, and the distance. This is your distance L, and so before it enters this region, it has initial velocity, and then after it goes through this region, it's being accelerated and emerge with the velocity. We call that Vf. Okay. So if you look at the information you're given the initial velocity, you're given the final velocity, you're given a distance. However, you're not given the time information. So based on the equations of motion, we need to pick the equation that has no time information. And based on what you're given here, we know that there's one equation that does not require the information of time. That is, the final velocity squared is equal to the initial velocity squared, and then plus 2 times the acceleration, and then times the distance that the particle has traveled. So if we look at this equation, you have this information, that information, and that information. So it becomes very straightforward to find out what the acceleration is. Okay. So in that case, your Vf is this 5.7 times 10 to the 6, and then you square it, and then that's equal to initial velocity, which is 1.5 times 10 to the 5th, and then you square it, and then plus 2 times the acceleration, which is the one that you're asked to find, and then times your L, and your L is 1 centimeter, so you want to convert it to meters, so it's 0.01. So after you work out the math, then you should get a numerical value that is equal to 1.62 times 10 to the 15 meter per second squared. Okay, so that's basically the first three problems that we covered.